Okay, Assalamualaikum, okay, and good day to all of you. So today we will doing the alternative method, which is we use the to find the member forces of truss. So before we know that we can find using the method of sections and methods of join to find the member forces of trusses. So this slide only the purpose to find all the member forces of truss using the alternative method. So why we need to find using the alternative methods? Because it's more easier, okay, and then you can save more time. We try to look at examples, okay. So this one is the truss given. So we have the external loads here, okay. And the first things to solve using the alternative methods, you need to know the determinacy, okay. So first of all, you need to identify the determinacy of truss. So by using the equation m plus r minus 2j, okay, so we know that the member is 7, which is 1, 2, 3, 4, 5, 6, 7. And R we have here pin and the roller, so we know that R is 3, the total, and then J is the joint, 1, 2, 3, 4, 5, 5. Okay, so using this one, we know that the truss is statically determinate. Okay, why not we go to the next one? Okay, how to start actually if we want to use the method of alternative. So first of all, to look this one. Okay, so from here you can start any parts which is involve at least two unknown forces. Okay, if you can see from here, we can start from here, okay, or we can start from here too. We cannot start from here, okay, because they will involve three member unknowns. Okay, so if we start here, we also can start here. How? So here in this part, we have the external loads, which is in Fy downward. So to make it stabilize, this one will be upward. Okay, dia akan jadi ke arah atas lah. So the total of unit loads will be 40 kilonewton. Okay, and this one we also have Fx. So this member truss, they are not parallel to Fx and Fy. So that's why we need to resolve two components of Fx and Fy first. So we already get the Fy. So now is the x that we need to find. So how to find x value? So this one you need to apply the mathematical method, which is like a proportional method. Proportional method. So from here, 40, okay, 40 which is referring to this one. So they will divide by EB. EB which is because this one, this truss, okay, in y directions, the distance, the length of EB, okay, and then equals to x, okay, over 3, which is this one, okay. So from here we can get x is 96, okay, 96 kilo newton. Okay, BE, actually how to find BE? So from the questions given, they are not straight. They're not telling you direct the length of BE, but they give you the length, this one, 2.5. And we have here the total length from A to C, we have 6 meters. So from here, we can find the angles here. Okay, so if we use the tangents, we get 22.61. So from by using the angles here, we can find BE, right? We can find BE. So that's why we will got 1.25. So from 1 to 5, we substitute this value, so you will get X will be 96. Okay, so finish these parts. You need to continue these parts because one member truss, they will have to resolve what we call the components of X and Fy. Okay, so to make it stabilize, upward there will be downward, which is 40. Okay, and then this one also we have the opposite directions. Okay, so we know that the arrow acted on the member truss will be look like this. Okay, same so here. So from here, how to find the member truss forces of EC? So you need to use like a theorem Pythagoras, 40 power of 2 and then plus 96 power of 2. Okay, and then you will get 104. Okay, the formula like you use theorem Pythagoras. Okay, so you need to square root lah, square root the value. So you will get tangents members. This one will be tangents members. Okay, so next you can continue this part, which is member BC. So what about the value? The value you see here exists X. Okay, so we have X here. We don't have any X, and also we don't have external force here in X directions. So we just get X, which is 96. Okay, and the directions will be opposite. Okay, so this one also you need to stabilize the next parts. So this one will be 96 in compressions member. Okay, so the next steps, you can go to these parts because we will have only two unknown, which is more easier because they are in X and Y direction. Okay, so you can get easily. So this one continue to the members AB, or you can continue members EB. Okay, so how about EB? So we know we have external force here, 40 kilonewton downwards. So to stabilize, it will be upwards, and the other parts will be downwards. Okay, so this one, the value, how about the value? We only have 40 kilonewton here, so that's why we only have 40 here. So the members forces here will be in tension. Okay, so the rest will be AB. So we know AB we only have here the direction Fx, because that one will be in one part. So make it opposite from this one. Okay, opposite, right? And then also we need to stabilize these parts. So the value will be 96, still in compressions member. Okay, so how about the rest? So after you finish this parts, you can continue the other parts. Dia tidak semestinya dari kanan ke kiri. You also can skip. Okay, so next. Okay, so we still not finished yet. This one, members DE, DA, and AE. So how to find these three member forces? So these parts you need to find the support reactions. Okay, because they will involve this joint and this joint. So kita kena cari dulu support reactions here. Okay, so how to find the support reactions? So this one will be the assumptions. So here rather we only have one unknown reactions. This one we will have two unknown reactions because pin supports. Okay, so we assume the directions will be look like this. Okay, this one HT, this one HA, this one is VD. So we take the moment. Okay, determine the support reaction using equations of equilibrium. So we know that F upwards equal to F downwards. So from this one, we can see we only have this one. The external forces, 20 plus 40 plus 40. So the equal will be 100. And upward, we only have VD. Right? Kita cuma ada VD sahaja. So that's why VD will be equal to 100. Okay. So The other parts, the other support reactions, we take the moment at D. Okay, we can take the moment also at A. So if we take the moment at D and we assume positive clockwise directions, so we will get HA is 144 and the rest will be also 144. Okay, okay. So next one, we can continue these parts. Okay, okay. So if you look at here, we have two unknown member forces, right? This one is Fy. This one, they are not parallel to x and y direction, and they have the angles, so meaning that we need to resolve to fx and fy components. So from here we can find fx. Okay, so how to find it? You look at here this part. So we have 144. Okay, the directions will be like this. Okay, this one, and then we also have 96. So the directions will be to the left lah, to the left. So to make it stable, we still have another 48 to make it equals to 144. Okay, so dia stable lah. So the balance will be 48. So we put here as a 48. Okay, and this one will be y. So y you need to find. So how to find it? Similar to these parts. Okay, so from here we have 48 and then over AB, okay, which is because AE, okay, so that's why we need to take the length between this one to E, okay, which is 3 meters, okay, AB equals to Y and divide by the Y directions, which is the length from here to here, okay, which is 1.25. So we will get Y is 20. Yeah? So we need to stabilize the other parts. The next parts will be downward. This one will be upwards. This one to the left. This one to the right. So we will have the directions of the member forces will be look like this. Okay, so by using the theorem Pythagoras, 48 power of 2 plus 20 power of 2 and square root, we will have 52 kilonewton, and the member forces will be in compressions due to the directions here. Okay, so how about the rest? Okay, so this one is 40. How to know that one is 40? Okay, you look at here. You'll just look at this parts only in y directions. So here we have 20, y is 20, right? So this one is downward, this one is downwards. To make it stable, we need to make it upwards. Okay, upwards, which is the value will be 40, and the next part will be downward, so we will get this one 40 kilonewton in tension. Okay, so how about the rest? The rest you can continue. If we look at here, so we have 100 here, which is referring to BD, and we also have here 40, right? So we have the rest or the balance is 60. Okay, how to find 60? How we know that one is 60? So here we have 100 upwards. This one is downward 40 to make it balance. So we need another extra downward direction, which is 60. So 100 minus 40, we get 60. So when we make the summation, this one will be 100 again. So balance lah, the balance. So how about the rest? So we can straight away take this one. 144, okay, for in fx directions. So we know that this one we need to stabilize to the next parts of member DE. So this one downward, this one upwards, okay, this one to the right, this one to the left. So we will get 109, 56 in tension. Okay, So macam mana dapat 156? So we already get this value. So 60 power of 2 plus 144 power of 2. The square root, we will have 156. The member forces is in tension. So finish already the alternative method. So from this, you can find all the member forces of truss. Okay, so then how to check the value is correct? Okay, you dah kira banyak-banyak. So macam mana nak tahu that one value is correct? So you need to choose one point which is critical point. So we can choose E. Okay, to check based on the equations of equilibrium. So E you check back here. So kita akan dapat sini based on the equation of equilibrium. Okay, you can see we can get equal. Okay, AT equal AT, this one will be equal 144 equal to 144. Just at joint E. Okay, so we can say joint E will be critical lah because they will involve many member truss. Okay, try to look at here back. Kita ambil semua nilai yang ada. Okay, so if you can see here, when you listed all the member forces in Fx and Fy directions, you can get that one will be equal. So what you find before, the value that you find before is correct. Okay, so you dah check lah. So we can take moment at A here. So we will involve 3 forces, which is 20, 20, and this parts. Right? So 20. So if we assume the moment is clockwise direction is positive, so 20 times 1 and 20 times 1, and this one VD minus, okay, because we assume VD is upwards, so they will move around point A in anti-clockwise, so they were negative, okay, times 2. Okay. So we will get VD is 20 kilonewtons upwards, and the rest will be 0. How we get 0? Based on the equation of equilibrium. Okay. Okay, so we find the support reactions. So how about here? Here we know this one is pin, right? So pin, we know we have horizontal reaction. So we only have one external forces in y-x direction. So we make it stable. So this one opposite direction, we have 20. Okay, so how to start? When to start? Which parts that we can start? Kita boleh mula dekat sini. Kita juga boleh mula dekat sini. Why? Because this one we have two unknown. This one also we have two unknown. Okay, mudah lah. So if I start with this parts, okay. So vertical at A is 0. Tadi kita dah cari, okay, vertical support reaction is 0 here. So this one will be 0. So of course lah, this one will be 0 member truss. So we do not need to continue to resolve to x and y components. So BA already 0. So this one will be 20 because we only have horizontal forces only 20 kilonewton. So make it the opposite like this. This another parts also we need to stabilize. So we will have this one 20. Okay, 20. Then we can start here. Okay. We cannot start at these parts because they will involve 1, 2, 3 unknowns. So you can jump to here. You boleh bergerak ke sini. Okay. So this one we have upwards. Okay. And then 20 kilonewton to make it stabilize is downward. Same to this one. So we have 20. This one in compression members. Okay, so how about the next one? We can start here. Also, this one is 0 member forces truss lah. Okay, because we don't have fx directions, forces in x direction. Right? Okay, Next, we can continue this one. So this one will be more easier. Why? Because ED is 0, so we only have these 3. So this one also will be 20. And how about this value? Do we have any forces in y directions? No. So that's why it will be 0 member forces. Okay, so we still need to solve this one. So these parts, if you look at here, we have this one. Okay, 20. So this one will be 20. Okay, downwards, because this one is upwards. To make stabilize, this one we need to downward. So this one also 20 lah. Okay, also 20. Then we can find the values here will be 20 power of 2 plus 20 power of 2 square root will be negative 28.28. So meaning that this one will be in compressions member. Okay, so finish already using alternative. Okay, we try to look at the next one, the last examples. Okay, I take these questions from YouTube, so we try to solve. So before we can start, we need to identify first the determinacy using m plus r minus 2j. So we know the truss is statically determinate. Okay, so we can check. So from here, we have pin and roller. This one you need to find the support reaction first. Okay, so we assume that one will be vertical direction, VA and VE. Okay, so we take this using the equations of equilibrium. So we know upwards equal to downwards. So we have here 5, 5, 10, 15, 5. The total will be 40. Okay, so VA plus VE is 40. So we take the moment at A, also we can take moment at A. So if I take moment at A and assume it's clockwise as a positive moment directions, so we will get VE will be 22.5, okay, and VA will be 17.5. Okay. So I start these parts. Okay, these parts only. So we know this one we have external. Okay, 5. And this one VA is 17. And 17.5. So to make it stable is 12.5. Okay. So from here 17.5 tolak 5 kita akan dapat 12.5. So how about the directions? If you can see here, downward, upwards dengan up. Downwards to make it stabilize. So we need another downward direction forces 12.5. So dia dapatlah kat sini. So this one will be 12.5 lah. So the directions in fx will be look like this. Okay, the arrow. You can see the arrow direction. So this one you need to find fx. So how to find x? So this one similar to this previous method using the proportionals. So 12.5, you look at this one is fy. Fy. So the members is here, BA. So should be fy direction of member BA will be BH lah. Okay, BH. And then x will be divided by AH, which is 2. Okay, so we get 25. So BH, the question already given to you, the length from here, BH is 1, B to BC is 1. It's 1. So that's why we just take away the value of BH as 1. Okay, so don't forget to make it to the another members parts, okay, which is downward, upwards, to the left, to the right. So you will get the directions of the member forces in member truss will be look like this. You will get 27.95. Macam mana dapat 27.95? This one you use the concept like the theorem Pythagoras. So 12.5 power of 2 plus 25, okay, power of 2 and the square root. So you will get this value. Okay, so the member forces in members BA will be in compression. Okay, so how about the next one? So this one we can solve. Why? First, we know that one x is 25. Okay, we don't have any external forces in x direction, so we only have this one. Okay, so you will get this one 25 lah, 25. Sebab x ni kita dapat 25. So to make it stable to the left, to the right, okay, also this part also make it stable opposite from here. So we have 25. The members will be in tension forces. Okay, so we can go to the next one. Okay, this one is more easier because we don't have the angles. So this one will be 0. Why 0? Why BH is 0? Because this part, if we refer to these parts only, we don't have external forces in y direction. So that's why we consider its member 0 forces. So HG, okay, will be from here, opposite directions. This one also needs to stabilize. So the value will be 25 in tension. Right? You can see now. Okay, next. So you can jump. Okay? You can jump to these parts because they have two unknown member forces. This one is more complicated. So we can start with first. We can jump. You continue the other parts. Okay, you can find CB and BG. Okay, by using also the method of join, or you can also using the method of sections to find the rest. Okay, I think that's all for now. I introduced to you the alternative methods, so try to practice more. Okay, so we have a lot of video in YouTube using method of joins, method of section, which is already given the member forces truss. So try to take that examples and you solve using alternative. Okay, to make it to practice more. Okay, using alternative methods. Okay, that's all for today. if we apply the using the equations of equilibrium, okay, we can get this value, these two value. So we will have two unknowns member forces in DC and DG. Fx also we will get two unknown members forces, okay, members DC and DG. So how to solve it? You can use calculator, okay, take the mode of equation, okay, you use the matrix lah, okay, equations matrix, you will get DC will be 22.37, okay, and then DG will be 16.78 in compressions member. Okay, so you also